Hello again. This is Graham Warren, looking at some simulated scenarios for the Antico Caffe Greco case with you. We have in front of us the base case. Um, we've This is the last of the clips dealing with this analysis of this cafe. So again, when you set this up, you want to go to wherever you have your um, in your project panel. You want to go to simulation main to set up your parameters. So this may be a little small in the video, but we have mean service time, arrival rate, standard deviation of the service time for the valves, number of valves, number of clovers, standard deviation of the service time for clovers. So in the previous clip, we explored the best case. And I think we got results that roughly chimed with what we saw in the queuing model analysis. So I'll try a few of those scenarios just to show you how this would look here if we went to a VAV. We switched out all the clovers for VAVs, and we kept the baristas independent. In other words, they're each serving a part of the cafe, and they're sitting 29 per hour. All we need to do here is just to switch out the number of VAVs to 0. Just to get rid of that. So this goes to 1, 1, and this goes to 0. Okay, and then go ahead and run it. So you run it with this little green thing here. And again, you'd want to run it 3 to 5 times. The more variability you have, apparent variability, the more times you'd want to run it. I think we should say just something about the length of the runs here. You'd want to keep them constant. The way I think this thing sort of times out is when 50,000 customers have gone through, it sort of automatically ends, and we've set it up that way because we are on a free version of the software, and that's the maximum number of entities that are viable in this model. Okay, so we ran this one time. We had, I think, when we estimated this using the queuing models, we got 1.584. Here we're getting 169. And the utilization on the valves is about 50%. So notice how there's a histogram for valve utilization here and nothing for the clovers because we've pivoted all the clovers over to the valves. All right, so I'm going to stop this one and then rerun it. And sorry about that. So I'm not sure what happened there, but there it is. We have to rerun it. Okay, so this time we're getting, I need to speed this all the way through again. Let's go. Getting 165 and again about 50%. So, the point of the multiple runs is to try and get a solid estimate of what's going on. I'm doing 3 here just to sort of emphasize the need for these multiple runs. You don't need to run them out to 19,000 minutes or 19,000 samples, customers. You could do less. You could cut it off at 10,000 or something. So that's a possibility to do this. To cut it off, you could set a max here. It's actually 19,000 minutes. You press these little 3 dots here, and you could say run it until, can we do that? Yeah, I guess we have to stop it. And then you could run it until 10,000 if you want to shorten this up. All right, so there it's running, and if I speed it up now, I see, oh, that one still goes to 10,000. So we'd have to research exactly how to do this, but I guess if I run it this way, pressing that run button. Um, well, it still goes to 19,000. Not sure what's going on there, but in any case, is there some sort of change in the software versus the last time I ran the code? So it's also not showing up particularly well. So it ran out to 19,000. You could just use that, getting results that are similar. All right, so that was the first change. And if we get the training in place, notice how service time, standard deviation of the service time for the valves is 30. If the folks are untrained, the baristas are untrained. If we wanted to go to having trained baristas on valves, then we change that out to 15. I'm not going to run it. It'll be the same process, just run it, do a few replicates, and either generate confidence intervals from the results or just average out the results at the very least and maybe get a standard deviation or something from the different replicates, just so that your results are presented with the variability apparent. All right, so the next one was trying the base case with 6 baristas. So let's go back to having a clover for the barista, for each barista. All right, and so we set it up this way, 0 and 1. We are back in the base case, so it doesn't really matter because the person's working with a clover. But instead of the 29, remember we refigured the arrival rate. Now the 205 customers are being served between by 6 baristas, so that's 205 divided by 6 comes out at 34.17. So I will run this one time for you. And one of the key things that is different here relative to the queuing is this histogram here. I don't think the histograms for the utilization are particularly useful. Maybe just is enough to just give the utilization percentage. You can see clovers are now 50%, 57% utilized. There's a little variation in there across the day. So it's not like every hour looks the same. But here's the interesting piece, right? With 6 baristas now, the wait times are about 1.72 estimated using the simulation. I think we got 168 with the queuing model. But notice how worst case situations here, probably up to 6-7 minutes, definitely more than 5. There's a little bump here, right? Don't know how many actually came in all up to 10 minutes, but got a sense of the worst case. And the worst case may be those worst case scenarios may be the ones that are a little frustrated when everybody else is getting their coffee and 2 minutes or less. They're facing 6, 7, 8, 9 minute wait. So you may get a hot tourist firing off a TripAdvisor review on that. Okay, so this, and you'd have to repeat this one 3 times. So I'm going to go back here and now look at how do we do pooling. So we're going to pool, take the base case and just pool. So we go back to 29. And then to do the pooling, actually, no, we need an arrival rate of 205. And then we'll just have them all 7 of them use clovers. And we should be able to run this and see how it goes. So this gave a superior result, right? The pooling was something of an eye opener. It took about 0.4 of a minute off, or maybe half a minute off. Just run this one to completion, just verify. Part of using the simulation would just be verifying what you're getting with the queuing. And then, of course, the one thing that you're not getting in the queuing is this histogram. So you could screenshot this or something. Probably not useful to include a screenshot of the whole simulation. Carlo probably it's not too familiar with any logic. But here it is, 47% utilization of the clovers and about a minute, which chimes with what we got on the queuing analysis. You'd want to run this one 3 times as well. So as a last one, what I want to do is just consider some sort of mixed model here. let's go ahead and assume we've got pooling. We'll go with 3 baristas, and we'll assume that 3 of them use 3 baristas on clovers, 3 baristas on valves, and we'll assume that the folks who are working the valves do have the advanced training. So we'll drop their the standard deviation of their service times to 15. All right, let's run this. So this sort of mixed model setup is, the only way we can sort of directly analyze this is using the simulation model. So that's one nice additional feature that we can do in the simulation that we can handle in the queuing without doing some sort of weighted mix of results from the DGK calculations. All right, so let's run this one to completion. If we hit go on this, we have, okay. So 6 baristas, waiting times around 104. You can see we've got 3 and 3 here. So 3 out of the 3 valves were in use at the time that the simulation ended. The same is true for the clovers. You can see that the valves are going to get the first business, and that's just the way this thing's set up. The resource pools are chosen, they have to be chosen in some order. Valves are going to be snapped up first, and then the clovers. And so that's why there's a difference in their utilizations. Notice how there's now sort of more of a distribution for both of these graphs. And worst case probably is just a little over 2 minutes here. So this is, just an example of one way of setting this up. Pretty low utilization here on the clovers, to be sure, right? There's 3 people and they're only busy about a third of the day. Hope you enjoyed this. Hope that you have enough here to sort of pick your way through to a superior solution. Enjoy.